You are watching Darasa Online.
Are you okay there? Today we're going to start advanced mathematics again, and the topic is algebra, and the subtopic is partial fraction, and you will be with me, your teacher, Johnny Kimat, and let's go see what are partial fractions and some examples, and remind ourselves on what can we do about this. Now, by starting, we shall define first, then we shall see some few rules of partial fractions, of partializing functions, and then we shall see some examples, and after that we shall have some few questions for you to practice. Now, to start with, let's start with the definition itself. What is a partial fraction? What do we mean when we say partial fraction? When we say partial fraction is the process of decomposing a rational function into simple parts. The process of decomposing a rational function into simple parts. Like what? Let's see. For example, there we have a function that says we have 4x minus 3 over x minus 1, and that is squared. And that can be decomposed into 4x minus 1 plus 1 x minus 1 the whole squared. Now, this process of decomposing this function into these two parts is known as partializing the function, and we shall discuss the rules of doing this as we go on. Another example is like that. We have a function like x raised to 3, we have x squared minus 9, and that can be simplified to x plus 9, x minus 3 plus 9x plus 3. So this process of decomposing this function into these simple parts is known as partializing the function. And the function we're talking about in this one, it has been decomposed to simple parts. Now, let's see, how do we do that? Now, let's check the rules. Let's check the rules on how we decompose a function into its simple parts. Let's check the rules. And what are those rules? To start with the first one. Now, in order for us to partialize, first of all, the function must be in a proper function. What do we mean by proper function? We shall see it as we go on. And the second rule is for those non-repeated linear factors. And when I say that, I'm trying to talk on this part. We have ax plus b raised to n. Now, the factors I'm trying to talk are these ones. Now, for example, we have a repeated nonlinear factors. That means our rule will be as ax plus b, then plus b c plus d, because these are distinct numbers, and then plus, let's say, c ex plus f plus down to let's say q over what? Qx, let's say, plus p. And this is raised to n. That means the last one. That means we have a lot of these factors, non-repeated. We have distinct one. We shall see as we partialize quadratic functions. We shall see that. Now, the third rule is for repeated linear factors. Now, these factors now are repeating. How do we do that? That means we have a function like this, plus b raised to n, and the factors now are repeating one after another. Then we shall have ax plus b. Then this is raised to 2, and that is ax plus b, and that is raised to 3, and that will be ax plus b raised to n minus 1, and that will be ax plus b raised to n. That means these factors has been repeating themselves up to n times. That means this will be the first one, the second one, the third one, then the numbers, then up to the nth one, And let's go and check the next rule. For reducible quadratic equation. Now we have a quadratic equation. Let's say we have f of x, then ax square plus bx plus c. Then this can be reduced to its factors. Now that means it can just go there. Then we shall have like this. We shall have a over factors, let's say d x plus e, then plus b over fx plus g. So those are 4 rules, and let's see. We have the next one for irreducible quadratic equation. How can we do that? We have a function like this. A x square. These functions are quadratic equations plus c, and we have another quadratic equation there is dx square plus ex plus f. That means, how can we do this? Now this cannot be separated into distinct roots as we saw it there. Now how do we do that? Then we shall be having something like this: ax plus b over that quadratic equation there, ax square plus bx plus c plus we have another quadratic equation that cannot be separated into distinct root. What are we going to have? We shall have a cx plus d over ax square plus bx plus c. Now those are some few rules we shall be using when we partialize function. When we decompose function into simple parts. Now remember, if the degree of the numerator is greater or equal to the degree of the denominator, then you have to divide by long division so that you can have a proper function. So for example, we have a function, let's say x raised, let's say, to 4 over x square plus 1. So you can't partialize a function like that. We have to divide so that we can have a proper function. Now let's see some few examples on how we can partialize functions.
You are watching Darasa Online.
Okay, let's see those few examples. Example number 1, we have 3x plus 5 over x over x minus 3, then 2x plus 1. As you can see there, these are two distinct roots. And by our rules, how do we reduce that? It is equal to a over x minus 3, then plus b over 2x plus 1. Now let's find the values of a and b. How do we do that? Let's add those. It will be 2x plus 1, then bx minus 3 over x minus 3, then you have 2x plus 1, which is equal to that thing there. Now opening the brackets there, we shall have 2ax plus a plus bx minus 3b over minus 3 2x plus 1, which is equal to that thing there. Then 2x plus 1. Now, what do we need to do here? We need to compare. Because this one and that one are equal, then we just leave them. Then we take this part here and that part there. So that means we have 3x plus 5 is equal to what? Is equal to 2ax plus a plus bx minus 3b. Then how can we do that? Let's collect like terms there. Then we have 2a plus b, and all of these have an x. Then plus a minus 3b, and this equals to. Now, by comparing the coefficients, we shall have the following equations. We shall have the first equation, this one shall be compared to that one, and that one shall be compared to all of that. Then we have 2a plus b is equal to what? Is equal to 3. So we can call this equation number 1. And there we have also a minus 3b equals to 5. And that is equation number 2. And now, what are we supposed to do? We are supposed to find the values of a and then the value of b, so that we can plug them there and have that function into its simple form. Now, we advise sometimes to make a good practice of your calculator, so you can just enter those two equations, and then you can have your answer. Now, how do you enter that? You go to mode and then up to equations. And how many unknowns do we have there? We have two unknowns. Then two unknowns, and the first coefficient is 2, equal signs, then 1, then we have 3. Equation number 1 is done. Let's go to equation number 2. We have a 1 there. We have a negative 3 there. Again, for C we have a 5. That means our answers are, for A we have 2 and B equals to negative 1. Now, we have to plug these values. And where do we plug them? We plug them there. Now, it will be like this. 3x plus 5 is equal to over x minus 3. 2x plus 1 is equal to what? We had an a there, and what is our a now? Our a is 2 over x minus 3 minus, because our b is negative 1, then it will be minus that one, minus 1 over 2x plus 1, over 2x plus 1. So, up to this point, we have already composed the function from this form to that form. That means we have decomposed this a little bit complex, but not that much, into simple parts. I do hope you understand. That's how we do use the rules on how we can partialize the function having two distinct roots like that.
You are watching Darasa Online.
Okay, now let's solve the next example. Let's solve the third one. We have x plus 5 and divided by x that way, and then x. Now, how do we do that? Remember, these roots are repeating. And the rule says what? If the roots are repeating, the rule for the repeating roots says like that. So what are we going to have there? We shall have an a. This one is not repeating. Then we shall have an x minus 2 plus what? Plus b over x plus 1, the first one, and the next one is c x plus 1, and that is squared. So let's find the values of a, b, and c. Let's find the values of a, b, and c. Now let's go. Then there, down there we have x minus 2, this and that means it will be a x plus 1 squared plus this and that means one going to cancel. Then we shall have a b of x minus 2 x plus 1 plus this and that means we shall have a c x minus 2, and this is equal to x plus 5 x minus 2 now let's simplify this into more simple parts. That means we shall have the following. There we shall have an a, and simplifying that or opening the brackets, there we shall have x squared plus 2x plus 1 plus b, and that can be like this, x squared this and that plus this and that is x, this and that is this times that is negative 2 plus c x minus 2c, and that equals to what? To x plus 5. Then let's open the brackets once more again, but remember here it's x squared. If you find the sum there, minus x minus 2. So if we open the brackets there, we shall have a x squared plus 2ax plus a plus bx squared minus bx minus 2b plus cx minus 2c, and that equals what? To x plus 5. Collecting like terms, there we shall have what? That means collecting like terms with these coefficients of x squares are to be collected, then the coefficient of x should be collected, and then the constants. Then there are coefficients of x square. We have a, and that is plus b, and all of these are x squared. Then the coefficient of x, we have there 2a, then again we have 2a, then we have minus b, and then there is plus c, and all of these are enclosed within x, and then we have a constant, that is a minus 2b minus 2c, and those are equal to what? Xc plus 5. Now let's collect the equations. As you can see there is no coefficient of x squared. That means we have a plus b is equal to 0, and that can be called equation number 1. And let's go to the coefficient of x. We have a 1 there, and there we have that equation. That means it is 2a minus b plus c equals to 1, and that is equation number 2. And let's have the constant. There we have that much. We have a minus 2b minus 2c is equal to a 5. That is equation number 3. Now, what are we supposed to do? We are supposed to find the values of a, b, and c. Now, again, let's practice our calculator uses by going to, again, to equations. Unknowns, they are there 3. So we have 3 unknowns. And then there, the first equation, we have a 1, again a 1, then a 0, and then a 0. And then there we have 2 minus 1, and then there we have 1, and then we have 1. And equation number 3 is 1 minus 2, and 1, then minus 2, then minus 2 again, and then we have a 5. Now what are the values? What are the values? So we have, for A, we have a 7 over 9, and for B, we have a negative 7 over 9, and for C, we have negative 1 and a 1 over 3. That equals what? This times that one is 3, plus that is 4 over 3, and that is a negative. Now, let's write that. That means our final answer could be like this. We shall have x plus 5 over x minus 2 x plus 1 square equals what? A, that is our A. That means it will be, if you write there 7 over 9, and you try to divide, what will you get? You get a 7 over 9 x minus 2. Then plus, is it plus or it's negative there? It's negative there. So again it's negative 7 over what? Over 9 of what? Of x plus 1. Again it's negative, then we have a 4 over 3x plus 1 squared. So this function has been resolved, has been decomposed to form that function, from that function. So this is how we partialize the function with repeating roots, That's how we partialize the function with repeating roots. Okay, you shall try this, the second one, but before you try that, I will solve for you one from this side, so that you can have another exposure to that,
You are watching Darasa Online.
Let's solve one example from this question for more practice. I'll help you with one example. Now let me solve the fourth one. And the fourth one. And why do I solve the fourth one? I solve the fourth one because it has characteristics that we have skipped somewhere there. So we have 1 over x minus 1 x square plus x plus 1. And her name is Agnes Nyakunga, and she asks us to help her partializing this. Now let's do it. As we discussed in the rules how to partialize, we shall follow the rules and we shall partialize this fraction. Now we know that we have a root, we have a factor, and we have a quadratic equation. And we don't know that quadratic equation, does it have roots or not? Does it have factors or not? Let's find. And the factors to that equation must be either repeated or distinct roots. Let's use our calculator to find the factors to that equation. We go to equations and then to degree, and that equation has 2 degrees. That means, let's say the coefficient of x square is 1 plus 1, okay, then 1, and the roots are complex. That means we can't use those 2 rules, because in order for us to use the rules, either repeated or distinct factors, they must appear there. But for that case, we have complex roots. That means we are going to have the following. That means it will be a over x minus 1 plus bx plus c, bx plus c over x square plus x plus 1. Then after that, we are supposed to find the value of a, b, and c. And let's check that out. That means let's add those. It will be a, x square plus x plus 1 plus x minus 1 bx plus c over x minus 1 x square plus x plus 1, and that is equated to x minus 1 x square plus x plus 1. So let's open the brackets and then we find the value of a, b, and c as we are supposed to. That means it will be ax square plus ax plus a, then plus bx square plus cx minus bx minus c, and all of that is equated to 1 because the numerator, the denominator and the denominator will go. That means let's collect the like terms. That means the square to the squares, that will be a plus b, and all of that is x square. Then let's collect the coefficient of x, that is that one. Then we have a minus b plus c, and all of that is x. And the constants are plus a minus c, and all of that is equated to 1. That means this is we have a 0 x square plus a 0 x plus 1. That means this one will be equated to that, and this to that, and that again to the last part. That means we are going to have a, the first equation, equal to 0. That is, let's say, equation number 1. And then equation number 2 is a minus b plus c is equal to 0 again. That is equation number 2. And the last one will be a minus c is equal to 1. That means this is equation number 3. Now we can use the calculator again to find the value of a, b, and c. But for you not to confuse or not to mix the coefficients, you can also write this. That means there we have a plus b plus a 0c is equal to 0, and that one will be a minus b plus c is equal to 0, and that is a minus a plus b minus c equals to 1. Why do we write like that? So that once you are trying to enter the coefficient to your calculator, you don't mix, because when it is like that, you can write the coefficient of a is 1, the coefficient of b is 1, and then in the place of a coefficient of c to be 0, you can write another number. You can mix. Also there, you can write another number. So in order for you not to mix, you can write like that to be much more clear. Now let's practice again the use of calculator, and I have my calculator with me. Let's again go to equations. We have three unknowns, and the numbers, the coefficients are 1 to the first equation, 1 again, and then 0, as I said earlier, and then 0, and then the second one is 1 minus 1, then 1, and the constant is 0, and then again we have 1, and we have negative, we have unamesilidi watoto mwalimu. Mislead watoto sio vizuri. So in order for you not to confuse this, let's write those equations like this. We have A in case of the equation number 1, B plus 0, C equal to 0, and then we have A minus B plus C equal to 0, and then the last one is A plus 0B minus C is equal to 1. Why do we write like that? So that you cannot confuse the coefficients, especially in the third one, even the first one, so that you cannot confuse the coefficients. Now let's use the calculator so that we can find the value of A, B, and C. And I happen to have my calculator with me. Let's go to equations, then 3 unknowns, and then 1 for the first equation, and then 0, and then 0, and then 1, negative 1, and then 1, and then 0. Then we have 1, 0, negative 1, and then positive 1. That means we have the value for A is 1 over 3. The value of B is negative 1 over 3. And the value of C is equal to negative 2 over 3. 2 over 3. Now let's use these values. Let's use these values to write that partial fraction there. Now it will be like this. That is to say we have 1 over x minus 1, x squared plus x plus 1 is equal to, our A is 1 over 3. And all of that is over x minus 1. Again we have our B, which is negative 1 over 3x plus C, which is negative 2 over 3, and all of that is over x squared plus x plus 1. Now writing that much correctly, we'll see the following. That will be 1 over 3, and all of that is x minus 1. So if you write like that, sometimes you can confuse yourself. So how can you write like that? Like this. You will see those two lines do differ. Minus, we can factor out that. Then we are going to have x plus 2, and all of that is over 3. Then again is over x squared plus x plus 1. Then what next? That means this 3 can come down. We have 3 x minus 1 minus x plus 2. All of that is over 3 x squared plus x plus 1. And that is 1 over x squared plus x plus 1. So that is how we partialize such kind of equation, You
are watching Darasa Online.
I have received one question from the viewers, a student like you who is watching right now, and she says, how can I partialize something like this? She managed to write a question. Like that. Thank you. Thank you for your contribution. Now, how do we do a question like that? Let's solve it. Remember, from the rules that we were discussing earlier, the rules that are used to partialize, we said that if the degree of the denominator and the numerator are either equal or that one is greater from that of the numerator, then we have to divide by long division. Now, how do we do that? Then that means we have an x squared divided by x squared minus 1. And that it goes like that. And then we shall have a 1 there. And then this times that is negative 1. If we try to subtract, what shall we have? We'll have this goes, and that one equals to a positive 1. That means the function x square over x square minus 1 can be written like that. 1 plus 1 over x square minus 1, minus 1, minus 1. So this now is the function. And the function we are supposed to partialize here is this function here. This function, so that we can break it down or decompose into simple part of it. And if you try to check it that much, well, this is a perfect square. This is a perfect square. So you can find the factors of that, and then finding the factors of that, that means the function 1 over x square minus 1 to be equals to what? Again, it's 1 over what? That's the difference of two squares. That is x plus 1, and then we have x minus 1, the difference of two squares. Then the rules of partializing this is fairly easy. Then we have a over x plus 1 plus b x minus 1, and this equals what? To 1 over x plus 1 x minus 1. That means we have to find the value of a and b, the value of a and b, the value of a and b. And how do we do that? There we have a 1 equals to what? This and that is a, then plus, and equals to what? A x, opening the brackets there, and this equals to what? Collecting like terms, we shall have a plus b x, and this and that one is plus negative a plus b, and then this equals to 1. And remember, these are the coefficient of x. That means there we have that thing. Okay, now comparing the coefficients, we shall have a plus b equals to 0, and then again we have minus a plus b equals to 1. Equals to 1. You can use a calculator to solve that, but for this case it's fairly easy. We can just eliminate. Or we can just make the subject there and substitute. Now let's eliminate. Let's subtract there. Then this and that equals to what? To 2a, and that is 0, and that is negative 1. And then a is equal to negative 1 over 2. And let's go back again and eliminate the b. The a, we shall have a let's add. If we add, then we shall have a 0, and then there we have 2b equals to 1. That means we have a b which equals to 1 over 2. Now writing that function, now it will be x square, putting the values of equals to what? To this one, that is 1. Then what is a? A is negative a half, so we plug a negative a half there. Then we shall have a negative 1 over 2 x plus 1 plus b is positive a half. Then we have x minus 1. And that is how we partialize a function that has equal degrees. And also, if you get a function that has the degree of the numerator is greater than the degree of the denominator, then do partialize that function. Divide and then partialize that function. So that is it for today, and you were with Kimati John. Thank you.